Virtual call centers are staffed by individuals working at their homes. Most home agents earn $10 to $15 per hour without benefits versus $7 to $9 per hour with benefits at a traditional call center. Regional Airways is considering employing home agents, but only if a level of customer satisfaction greater than 80% can be maintained. A test was conducted with home service agents. In a sample of 300 customers, 252 reported that they were satisfied with service. Test to determine whether the sample data support the conclusion that the customer service with home agents meets the Regional Airways criterion. Use alpha equal to 0.05. Also, what is the p-value? So they want to show that the customer satisfaction is greater than 80%. Now, how are we going to set up the null and alternative hypothesis for this? If they want to prove that it's greater than 80%, that's going to have to be the alternative hypothesis. Remember, the only thing that you can really prove in a hypothesis test is the alternative, right? Because you either reject the null or you do not reject the null. And do not reject doesn't mean that the null is true. So you really, in a 5-step hypothesis test procedure, never show that the null is true. It's always to see if there's enough evidence to reject the null, and there either is or there isn't. So if we really want to prove something, it has to be the alternative. And what they want to do is to prove that the percentage, notice that I'm using p here for percentage instead of mu for the population average. The population percentage, they want to show that that is greater than 80%. The null hypothesis would be assuming then that the population percentage is 80 or lower. So this is how I would set up, this is my first step of the hypothesis test, how I would set up this problem with proportions. Now, let's look at the sample data. The sample percentage, there were 252 out of 300 that were satisfied with the service. And that turns out to be 84%. So there is some evidence that the customer satisfaction may be greater than 80%. There's evidence. But remember, this is only a sample. And what we want to be careful of is to show that this evidence is strong enough to reject the null and therefore prove the alternative, that the customer satisfaction is greater than 80%. So hopefully this will be enough evidence to prove that. Step 2 is the sampling distribution. And for percentages, the center of that distribution is going to be the 80%. Now, we always use a z-table or normal distribution to work with the sampling distribution of the proportions. There are conditions on that. If you remember, that would be taking the sample size times the population percentage, and that should be greater than 5. And a sample size times 1 minus the population percentage also has to be greater than or equal to 5. Those are the conditions for using the normal distribution. And if my sample size is 300 and we're talking around 80% as the population percentage around that, we certainly have both of these conditions being met and therefore can be pretty comfortable in using the normal distribution. Now, at a 0.05 level of significance, this is a upper tail test. And I'm going to go ahead and calculate my standard error. Remember, the standard error for percentages would be taking, now we're assuming that the population percentage is 0.8. So that's the one we're using. So I've got the square root of 0.8 times 1 minus 0.8, or 0.2. and then divided by the sample size, the square root of that whole thing. And that turns out to be 0.0231. So 0.0231 is my standard error, or standard deviation of the sampling distribution. Again, some of the things that we worked with confidence intervals concerning proportions are coming into play here. Our standard error formula is different for averages. Also notice that I'm using the 0.8, the value that I'm testing against in the hypotheses, as opposed to the 0.84, because I'm assuming the 0.8 is the one. And until we have evidence enough to reject that, we're going to use the 0.8 as the center of the distribution, and also the 0.8 in the standard error formula. Now I need a z-score for this. Again, we don't use the t-distribution here. This will be 1.645. Common enough that you probably even remembered that. And I'm going to reject h sub 0 if my test statistic is greater than 1.645. And to calculate the test statistic, the z-score, I'm going to take my sample percentage, p-bar, it's called, and subtract what I'm testing against, divided by my standard error of 0.0231, and I get 1.73. So step 5 is reject h sub 0. So in rejecting h sub 0, I've proven the alternative true. So the customer satisfaction is greater than 80%. And so they can move forward in these call centers because they have statistical proof, significant proof that the customer satisfaction will be at greater than the 80% that they desired. Now, we could also run this test using a p-value. And I'm going to use my z-test statistic of 1.73 and look that up in the z-table. As you look that up, of course, you will be looking at the normal table, the standard normal table with positive z-values, and I'll go down to row 1.7 and then over across to column 0.03, so I get 0.9582. 0.9582. So if I'm looking up 1.73, the area under the curve to the left of that is 0.9582. But what I want for a p-value is actually to the right of that. So what I've got to do is I've got to take that 0.9582 away from 1, and I come up with 0.0418. So since 0.0418 is less than 0.05, we reject h sub 0. So running the test with a test statistic compared to a critical value, which we did first, or running it with a p-value will yield the same result. Now, notice that 1.73, I'm going to go back over here to step 2, that 1.73 z-value the p-value is actually the area under the curve above that, and that is my 0.0418. So there's really two ways to run this test. One is the way I did first, is to calculate a test statistic and compare it to the critical value, the 1.645. The test statistic 1.73 is greater than 1.645, so the 0.84 is going to be to the right of that line. In other words, it's far enough away from the 0.8 to go ahead and reject the 0.8. Or I could run this with a p-value. The area above the test statistic 1.73 is 0.0418, and that's less than 0.05. And since that's true, the 0.84 again is to the right of the line, far enough away from the 0.8 to get the rejection. Now, a couple other things here. The p-value is really the probability of making a type 1 error based on the sample average of 0.84. The level of significance, 0.05, is the maximum allowable probability of making a type 1 error. So the people that ran this test wanted no more than a 5% chance of rejecting the null and being wrong. In other words, they didn't want to go ahead with this with any more than a 5% chance of that being an error. So they set the level of significance at 0.05. Now the 0.84 turns out it's further out than it had to be to get a rejection. The p-value is the actual probability of making a type 1 error, or you can think of it that way. So the probability of making a type 1 error is 4.18%. The maximum allowable to satisfy the people running this test was 0.05. So yeah, they're within that percentage. They even have a less chance of making a type 1 error than what they were requiring. So even more so, they can feel confident in rejecting the null hypothesis.